Hey guys, today we're going to talk about the zero product property. Now this is something we actually talked about towards the beginning of the year, but today we're going to go into a lot more depth with it, and we'll actually be able to see how factoring can be used to solve some different equations. So we'll start off just by reminding ourselves what this property is saying. So this property says if the product of two factors is 0, then at least one of the two factors has to be 0. So if you're multiplying two things together and it equals 0, one of those two things has to be 0. And our way of writing that, we say for any real numbers a and b, so any real numbers a and b, so a and b are elements of the real numbers. If you do a times b and it equals 0, well, if this is true, if ab equals 0, then either a equals 0, b equals 0, or a equals 0 and b equals 0. So either one of them is 0 or they're both 0 in order for this to be true. That's what the zero product property is saying. And what you're doing there is you just have a times b equals 0 and a is 4. Well, then b has to be 0. What we're going to look into is maybe a is, instead of being a number, maybe it's an expression, it's 2x. And maybe b is, instead of a number, maybe it's an expression, x plus 1. So we might see something like this. A is 2x, b is x plus 1. You're multiplying these two polynomials together and it equals 0. Well, then one of these two has to be 0. So either 2x equals 0, which means x could equal 0, or x plus 1 equals 0, which means x would equal -1. So these are going to be the two solutions to the equation. And if you go back to this equation here, well, if you plug in 0 for x, you would end up with 2 times 0 is 0, times 0 plus 1 is 1. 0 times 1, that works. If you were to substitute in the -1, you would have -2. -2 times, or 2 times -1 is -2, times -1 plus 1 is 0. See how it's going to work there? These are going to be your values that zero out the two factors being multiplied. So let's look at a couple of examples and then see how factoring is going to be really huge here. So our first example, we have 3b times the quantity 9b minus 18, and that equals 0. So here, notice how we have two things being multiplied together. They're not necessarily numbers, they're not constants, they're polynomials. We have the monomial 3b is being multiplied by the binomial 9b minus 18. So in order for this to be true, one of those two polynomials has to be 0. So we have a couple of possibilities. Either 3b is 0, in which case b would be 0, or we have the possibility that 9b minus 18 is 0, because if this whole thing equals 0, it'll still make everything equal 0 when we multiply, which would make b equal to, well, you add 18, divide by 9, you get 2. So our two possible answers here are b could either be 0 or b could either be 2. And if we want to check to see if they're right, we'll make a little solution set here. Our two solutions are 0 and 2. Let's check and we'll see if they actually work. Well, the first one, 3 times 0 times 9 times 0 minus 18. Does that equal 0? Well, 3 times 0 is 0, and 0 times -18, yeah, that's still 0. So this solution works. Solution of 2, well, 3 times 2 times 9 times 2 minus 18. Does that equal 0? 3 times 2 is 6. 9 times 2 is 18. Minus 18 is 0. So this equals 0. So that solution works as well. So both these are possible solutions to the equation. Let's look at another one, a little different this time. Our next one, we have the quantity 2d plus 6 times the quantity 3d minus 15, and that equals 0. So this one is different because Now instead of multiplying a monomial by a binomial, we're just multiplying two binomials together. And in order for this to be true, we're not going to multiply them out, we're going to think about it. We're multiplying a polynomial by a polynomial. Like this is your A, this is your B, you're multiplying these two factors together, they equal 0. So either the first one, 2d plus 6 equals 0, and if that happens, well, 2d equals -6, d should equal -3. That's one possibility that would make this equation true. Or the other possibility is if this factor, this polynomial, is going to equal 0. So 3d minus 15, well, 3d equals 15, so d could equal 5. These are our two possible values of d that if we substitute them into this expression up here, it'll make this expression equal 0, which is our goal. And I'm going to check these answers, make sure these solutions work. Let's go ahead and erase down here. If we take our -3 and substitute in, we're going to end up with 2 times -3, which is -6 plus 6, times 3 times -3, which is -9, minus 15, which is going to be -24. -6 plus 6 is 0. 0 times -24, well, 0 times anything is 0. So this solution works. And our other possible solution was having d equal 5. Well, if we substitute in, 2 times 5 is 10, plus 6 is 16. So 16 times, well, 3 times 5 is 15, minus 15 is 0. So 16 times 0, well, that's equal to 0. This makes the equation work as well. So we're going to see this as one of our strategies when solving equations that are a little more complicated. If we can get a 0 on one side and set it up so it's two polynomials times each other, then we can use this logic to isolate or to solve for the possible values of, in this case, d, that will make the equation equal 0. And we're going to do a couple of examples where we might see that and how we can use factoring to get there. Alright, so our next one, we have this equation. C squared minus 3c equals 0. So, if we look here, we have 0 on one side, but here we're subtracting two polynomials. We're not multiplying them together, but here's where the factoring is going to come in. Is there anything in common that we can factor out here? Well, if we look, they have a c in common, so we're going to factor out a c. If we factor out a c, we're left with c minus 3 equals 0. So c times c minus 3 equals 0. And now we have a times b equals 0. So either c equals 0 or c minus 3 equals 0. Add 3 to both sides. We have two possibilities here. Here's our first one. Here's our second one. Our solution set would consist of 0 and 3. If you go back to your original equation, if you put a 0 in for c, 0 squared minus 3 times 0, well, that's going to make it work. 0 minus 0 equals 0. That's true. So this solution worked, our 0. And let's see if 3 works as well. So 3 squared minus 3 times 3 equals 0. 3 squared is 9. 3 times 3 equals 9. 9 minus 9 is 0. So this one works as well. So these are our two possible solutions. A good thing to know, when you have an equation, the degree of that equation, like this is degree 2, it's a quadratic equation, you're going to have at most two possible solutions. So we have two solutions here. You could have one solution or 0 solutions, but at most you're going to have 2. So you're going to try to find both of those solutions. In this case, we have 2. Alright, our last one. And this one, let's make it look like this. N squared plus 5n, we're going to say equals 6. Now to use the zero product property, we need to, actually I'll say equals -6. We need to figure out how to get 0 by itself. Because it needs to be equal to 0 to use that logic of two things times each other equals 0. So clearly here, we're going to set this up, get this 6 over to the other side so we're equal to 0. To do that, well, you would add 6. And now we're left with this quadratic trinomial over here, and we're going to try to figure out how we can turn this into multiplication of two polynomials. Well, we just talked about factoring the past couple videos, so let's factor this. We're going to have n times n to get the n squared. Now we're looking factors of 6 that add up to 5. Notice it's all positive here, so plus and plus. So when we factor, we should get 3 and 2. 3 times 2 is 6, 3n plus 2n is 5n. So here's our factored version. And now we just need to solve. So the logic that's going through our minds here should be, well, n plus 3, that times n plus 2 equals 0. So either this binomial equals 0, or this binomial equals 0. One or the other has to equal 0. So either n could equal -3, or n could equal -2. Those would be our two possible solutions here. And let's go ahead and check and see if that works. So we're going to go all the way back to the original equation. It should work for any one of the equations. Let's go back to the original. If we put -3 in for n, -3 squared plus 5 times -3 equals -6. -3 squared is 9 plus -15 equals -6. Well, 9 minus 15 is -6, so it works. Our -3 is correct. And let's check that -2. -2 squared plus 5 times -2, does that equal -6? Well, -2 squared is 4, plus 5 times -2 is -10. 4, essentially minus 10, is -6. So yay, that works, and we're all done. This is where we're going to go, especially with factoring moving forward, is how can we solve. We're mainly going to focus on quadratic equations by using factoring. And that whole process that we did, I'll show us again here, was to get n squared plus 5n, and then bring the 6 over, get it equal to 0, because then we can factor things out. And we can turn it into something where we're multiplying polynomials together, and we're equal to 0, so we can use that zero product property. There are other ways to solve equations with that power of 2, but this is a really useful way, is using factoring to set up the zero product property. Alright guys, so go try some on your own. If you're having any trouble understanding the concept of this, we can set up a little extra help day to really go over this. This is a big part of what we're going to be doing in the future. Alright, have a nice day.